We'll move on now to our next speaker, Joel Werner, who's the Director of Engineering and Products at DP World Canada. Joel Werner has more than 20 years of experience in the design, operation, and maintenance and reliability of port mining and industrial assets. He has spent the last 15 years in the port industry managing equipment acquisitions, terminal infrastructure projects, improving asset performance, and operational processes. Since joining DP World in 2005, he's held several technical and operational positions. In his current role, Joel is responsible for all engineering, maintenance, and infrastructure delivery functions for DP World across its 5 Canadian marine terminals. Please join me in welcoming Joel Werner. Thank you, Joel.
Thank you, Erin, and welcome to everybody. And it's a pleasure to be here to talk about electrification and hydrogen from the terminal operator perspective. So let's just jump into it. Into the next slide, I'll just give a quick overview of who DP World is for those that aren't familiar with us, and then jump right into the meat of it. So DP World is a global operator of ports and terminals and other trade-related businesses. I think some people are familiar with that. Things people may not know is we're the leading investor in Hyperloop technologies and developing some pretty innovative container storage solutions, such as the high bay storage you see in the center here. Next slide, please. So in terms of our global footprint, DP World operates over 150 operations around the world, headquartered in Dubai. And mentioning the Ever Given, initially we handle over 70,000 vessels at our terminals each year. And in 2020, we handled 71 million 20-foot equivalent units, so 71 million containers across our terminals. So one of the top 3 global operators. Next slide. So bringing it closer to us here in Canada, as Erin mentioned, we have 5 Canadian terminals. So starting on the East Coast, we operate a terminal in St. John, New Brunswick, which I'll talk more about. And then on the West Coast, we operate four terminals, Prince Rupert, 2 in the Vancouver area, and 1 on Vancouver Island in Nanaimo. We also have a number of other businesses, short sea shipping in different logistics centers, and have expansion projects underway at 4 of our terminals right now, which I'll talk a bit more about. To the next slide. So just briefly, why we care about energy. It's one of the ways we lead our business. So we have a focus on community and environment and technology and innovation as ways forward. And you'll see why energy management and the transition to electrification and hydrogen is a way that we see to get there. So just to jump to the next slide. So in terms of sustainability, our sustainability strategy, one of the key pillars of it is addressing climate change and the impact that we have on our communities. And you'll see that our terminals are often located adjacent to large communities, Vancouver, St. John, and in Prince Rupert right beside it. So you'll see that the way we operate our business has a big impact, and we've recognized that and are aware that we need to address that if we want to continue operating and growing in the future. So on to the next slide. So talking about energy management. So why do we care about energy management? We see this, we're motivated as this is the path forward for us to develop sustainable operations. And sustainable operations, we see are ones that are economically feasible. They can coexist beside urban centers. And this picture is of St. John in New Brunswick. And you can see the terminal we operate is right against the downtown core. So we're very aware of the impact our businesses have on communities and the environment, with the majority of our container handling equipment currently powered by diesel and gasoline sources. And if we want to continue to grow and develop these operations, as well as build new opportunities, we have to take a different approach to the energy we're consuming and transition it. So as a good engineer, every place to start is by measuring, and assembling your data. So we have a methodology that we take all of our fuel sources, whether that's diesel, gasoline, natural gas, propane, electricity, we boil it all down to megajoules, so the energy, and we divide that by our total terminal moves, TTM, which is basically the work we perform. So we look at the energy required to perform 1 unit of work across all of our businesses, and that's how we judge our progress and where we're going. So from there, we can identify opportunities to firstly save energy, and then from there, transition that energy. The next slide. So the strategic approach we took a few years ago was 3 phases. The first was to reduce and manage our energy. So by reducing fuel, finding easy fuel saving opportunities and electrical opportunities, transitioning to LED lighting and things like this, which are quite easy to do. In the medium term, which we're now in right now, we're looking at retrofits to different powertrains, looking at hybrid solutions, just how you see a lot of like the automotive industry going hybrid, battery, diesel, different ways like this. And this we see as an interim transitional phase to get us in the direction we need to go. And then in the longer term, we need to get to solutions that are fully electrified, which can then be powered through renewable energy and energy storage solutions that could be powered by hydrogen. On to the next slide. So recent progress, what have we been doing? So as I mentioned, energy and emissions reduction, a bunch of those. We've been trialing hybrid powertrains, fully electric battery powered vehicles for a number of years now. We've studied hydrogen, electrification, CNG, LNG across our terminals to see where the applications could be, where the transition pathways could exist. Worked with many of the OEMs, the equipment manufacturers of the physical assets that we use in our businesses to try and understand of that. And we've identified a bunch of challenges that are preventing us or are slowing our transition today. We have very energy intensive applications. So you can see a picture of a reach stacker here. This machine lifts a 40-ton container 20 to 30 times an hour in and out of the stack. So constant requirements for peak loading again and again and again, and it does this 24 hours a day. In working with the OEMs, original equipment manufacturers that supply our equipment, they are not ready, or they are still developing the technologies to help us move to electrification or hydrogen. And then some of the things that were mentioned before, having good supplies and access to hydrogen or LNG, as we've studied in the past, is critical. And there's challenges depending on where our terminals are and the remoteness of those terminals. And lastly, impact operations. It's important that we are able to fuel and return the equipment to our operations as quickly as possible. So the ability to take the machine out of service, resupply it, whether that's hydrogen or whatever fuel it is, in a quick manner and return it is critical. And we've seen some challenges there. On to the next slide. So what do we have deployed today at our terminals? We have several hybrid and fuel saving powertrains deployed. We've got some next generation battery electric vehicle powertrains under testing. We're working on 2 potential hydrogen projects, one in St. John with some of the people on this summit today, and on one of our terminal tractors. And on the West Coast, we're working with a couple of Canadian technology providers to develop a hydrogen fuel cell powered RTG. So that's a rubber tire gantry, and those are those orange yard stacking cranes in there that typically run on a 600 kilowatt diesel power and transition that completely to hydrogen over the next year. So I would say we're at the beginning of the transition to clean energy. Jump 2 more slides quickly over. So, or just back one. I've always thought this graphic really demonstrates well where I think we're at, starting from the left side, where we were just running everything off diesel. We're slowly trying to move to the right, where we move through a phase of getting out of diesel into maybe more battery powered, but there's limitations in the applications where that works. And then we need to continue the march to the right to hydrogen fuel cell powered solutions over the future. So I would say we're about 20% from the left side of this graph and looking for pathways to the right. And just the final slide. So I think the way we view it is we need to completely rethink the way we operate our terminals. If we want to continue growing, we need to firstly transition to electrification, all of our applications as fast as possible. And this basically will enable hydrogen powered energy sources to work in our terminals. So in the short term, that electrification may be powered by batteries, but ultimately we need to find ways, whether that's fuel cell powered solutions or others, but we need to fundamentally rethink the way our terminals operate if we're going to continue to exist. And this pictures of our terminal in Prince Rupert, and you can see it's in the beautiful wilderness there, and we need to absolutely scale down our emissions and find ways to be sustainable there. So thank you, Aaron. That's the last slide.